Welcome to today's webinar. I am Jeffrey Palermo, your host, and happy to be able to talk about automating DevOps in iteration 0 right from the beginning. We have a really good crowd of people on this webinar, and so we will get right to it. I want to be respectful of everyone's time. We have a lot to cover, and so we're gonna get into it. A few logistics. If you haven't done a Zoom type webinar before, there is a Q&A window, and I invite you to submit questions, and I'll get through kind of the core of the content and then switch to questions. And if there are invariably some questions that fit right in, and I'll answer those along the way. But I invite you to do that. And also, look at the chat window. There are some resources and some information that Melanie is going to assist me with by putting those in the chat window, kind of a back channel. And we have quite a few resources to pass along to you that could be useful. So why don't we really get into this? A little bit about ClearMeasure for those who have not been attending our regular webinar series. ClearMeasure is a software architecture company headquartered in Austin, Texas, and serving North America. And what we really love to do is equip your team to be effective so that your team can establish a high bar of quality, achieve stability in your production systems, and also to increase the speed of delivery. And so we love empowering people who are doing software delivery. That's really fun for us. You can find us at clearmeasure.com. And one of the things we do a lot of is software inspections, and our total software inspection, as well as our 30-point DevOps inspections. Those are really popular products because somebody will have a hunch. They'll say, I know that our production system is not supposed to be going down once a week, or I know that we're not supposed to have this many bugs coming through, or I know that we were supposed to have a decade-long run on this software system, but one of our developers is saying that we need to rewrite it from scratch. What's going on here? And so an inspection helps you to get that information so that you can make sure you're not missing something and get on the right track. And we come alongside your team and help fill the gaps. As a software architecture company, we are not looking to compete against your internal team. Our goal is to make your internal software team awesome. And so we have a lot of free resources. We do these webinars for free, as well as all of our services. So as we go along, the code that I'm going to reference a few times in here, you can get all of it for yourself on the ClearMeasure Labs GitHub account. And so if you want to screenshot that URL, then you can go ahead and grab that code and clone it for yourself. It's pretty easy to find if you go to the ClearMeasure Labs GitHub account. All right, a few other resources that I'll touch on. My latest book, .NET DevOps for Azure. If you would like a free electronic copy of that book, then just you can send me an email, or right here on this webinar, you can ask Melanie in the chat and get your information and get you that for free. Of course, you can buy the book anywhere books are sold. And also, I'm also host at a pretty popular podcast. If you search for Azure or DevOps in any of the podcast directories, it seems to be reliably up in the top 3 or top 5 the podcast if you search for either one of those keywords. But it's called the Azure DevOps Podcast for anyone who is shipping software using Microsoft technologies. And so that's what that's for. All right. And as we go along, this is our last little resource plug. We have a video series called Programming with Palermo. And you can find that. You can just search for podcast directories. You can also go to the ClearMeasure YouTube channel. And whereas the podcast is interviewing industry experts, Programming with Palermo is where I get to teach directly. Of course, I love to teach from these webinars as well. All right. As we get into it, I'm going to launch a quick poll because what I'd like to just gather a little bit of information. Who is using what version of .NET? And then what type of work do you do? So do you code all day, work on the software, or do you lead or help lead a software team as well as programming? Or are you in company management? You don't really do the programming, but you kind of oversee some people who are doing the actual software. So we'll let you kind of fill that in. And as we go forward, there is too much information to cover in just a less than 1 hour webinar. And so I'm going to focus on the front end on this. When we talk about automating DevOps in iteration zero, the concept of iteration zero is that we need to get into some type of iterative delivery sequence, and we need to start somewhere. So what are the things that we need to put in place right off the bat for a new software project? And when I say new software project, you could say, you know what? We need a new batch job, or we need a new offline service that processes messages. Anyway, we need a new something that is going to be deployed. You could be trying to follow the microservices pattern, or it could be a net new application, or it could be a new application that's part of an existing larger system. Whatever it is, you're creating a new Git repository, and you're creating something new that is going to need to be deployed to production. And so you need all the prerequisites leading up into that. And if you skip some of them, your life's just going to be harder than necessary. Because ultimately, we want to have this thing running in production. We want it to be stable. We want it to do its job, not go down, no business disruptions. And for that to happen, we have to establish a high bar of quality, as opposed to just shipping bugs and then our users are telling us, hey, this doesn't work right, this doesn't work right. And now we're just doing a fire drill because we're trying to fix bugs. We need to make sure that we're not sending bugs into production. We need to send good features that are of high quality. And then with quality established, with stability in production achieved, then we can turn our attention to moving faster and delivering new capabilities at a really good pace. And teams that do this end up going at a faster pace than business counterparts can keep up with. Because when I say that, I mean, the business counterparts, they're responsible for analyzing the market that's out there and your body of customers and coming up with ideas for how the software can help the business. And then fleshing out those ideas and figuring out what to do. And then also to get the customers and get the market to use the new software capabilities. And that takes time, and that takes a lot of work. And some companies, for less than effective software teams, the story is, oh, I'm waiting on the software team. I'm waiting on IT. I'm waiting on development. That's not a good place to be in. And so we want to put these practices in place. A lot of automation, but a lot of it's commodity. It's known these days. There's really good tools out there. Put this in place so that your team can go. You don't want the business to be waiting on your team. You want your team to go as fast and then faster than your business counterparts. So that's kind of the challenge that I want you to kind of understand there. All right. So here is the framework. Here's the overall DevOps architecture that we've developed here at ClearMeasure. And again, we did not invent this. We put this together, but it's harvesting all of the good practices from so many years out in the industry and consolidated down to an easy to understand architecture for a DevOps environment. This is the process that you want to get in place during iteration zero. And by the way, this is a lot of information on this poster. There's no way we're going to get through every detail in this webinar, but that was just the top third of the poster. Here's the full poster. If you would like a high resolution PDF of this poster, then just put an email in the chat or look for the link there. And if you kind of miss it, just send me an email again. We'd be happy to equip you with a high resolution version of this poster. It's really meant to be printed at a print shop on 2 foot by 3 foot poster board paper, or maybe styrofoam poster board, and so you can do that. But we're going to focus on some of the steps in the top 1/3, from builds to multiple layers of automated testing to packaging release candidates, to basic static code analysis, and then packaging and getting ready for deployments. Now, we do have planned an upcoming webinar that we're going to be doing a sneak peek with. We're going to be doing a webinar with some experts from Octopus Deploy, going deep into some of the details of the actual deployments. But we're going to talk about the process right now. So we're going to be focusing on how to think about this and an understanding of all of the elements that you need to have in place during iteration 0 to create an automated DevOps environment for your new piece of software. Okay, and there's two primary tools that you're going to use kind of for orchestration. You're going to use a build server, and you're going to use a deployment server. Azure DevOps has both of those built in. The build server is more mature. There's plenty of people using it for deploys as well, but a lot of people graduate from Azure Pipelines on the deploy side to Octopus Deploy whenever their needs get more sophisticated. Because Octopus Deploy is in the .NET space, it's the first and the most built out and most mature deployment server to pair with a build server. So just kind of level set on some of the infrastructure. If you're using TeamCity for builds, if you're using Jenkins, if you're using GitHub Actions, that's all fine. Any of those will do the job. Okay. And this is just an example in Azure Pipelines of what it looks like when you have the full pipeline modeled. If I go to the next screen, we build the application, then we deploy to our TDD environment, then to our UAT environment, then to production. And you see that it's a multi-stage pipeline, and it goes from left to right. You want your pipeline, you want to be able to visualize it and connect it. You go from left to right, just like on a work tracking board using Kanban style. You take cards or issues or tasks, whatever you want to call them, and you move those in statuses from left to right. One of the common mistakes that some people use when configuring these tools is they don't actually set up a flow. They have environments stacking vertically instead of left to right. So I want to stress that when you visualize it, you want it to go left to right. Now, every team is going to have a minimum of 3 environments. Why? Because you have a minimum of 3 distinct types of environment. Everybody has production. You need at least one of those. Then backing off from that, you need an environment where you can have somebody completely test out the software. And a common name for that is UAT, user acceptance testing. You also have staging. You can call it whatever you want. And you can have as many manual test environments as you want. Different versions of the word test or verification. Then backing off of manual test, you need at least one of those. Now we have a test automation environment. I like to call it the TDD environment to invoke the concept of test-driven development. And that is not for manual testing. It's for automated testing, automated full system testing. And that is where no humans are allowed. When we build a new version of the software, we automatically deploy it to our TDD environment, and we automatically run a test suite of full system tests. Whether you do it in the acceptance test style or Gherkin, the given when then, that doesn't matter. The fact is, these tests require a fully deployed version of your entire application on a production-like environment in order to run. Okay. So if you have some screens that you pull up in a web browser, then you're using tools like Selenium or Playwright to type in text boxes, to click buttons, and make sure that the screens do the right thing, as well as setting up data in the database behind the application. So just want to level set. I'm going to pop away from PowerPoint just for a second, and I'm going to show you the application that we're kind of using as illustration. And so I'm going to actually run the build. And what I want to do is I want to pull open Visual Studio, and you see how we have some projects over here, and this is the PowerShell build script, which I'll get into. And then we have a directory that is our working directory of our Git clone. And I'm just going to double click to build.bat. Okay. While this is running, I'm going to pull open our SQL Server Management Studio, and the database for this guy is named Church Bulletin. It's just a test Church Bulletin application. And notice that there's no Church Bulletin database over here. There's some other just test databases, but not Church Bulletin. And so our build, one of the things that you want right off the bat, right from day one in iteration 0, is you want to equip your development team with a private build script, a way to run the build and run whatever test you've accumulated locally. And that's what this is doing. My hands are not on the keyboard. This is just running the build script. And one of the things that it does is it compiles, it sets up the local development environment. And one of the key things of setting up the development environment is to create the database that you're locally. So let's go over to the database here, and let's click on the refresh button. And there we go, Church Bulletin. And of course, this isn't a big database. It's just a sample application. It only has one table, but let's select the rows of the one table. Okay, we got 4 rows. All right, so we created a database from scratch, add a new table. Oh, and we put some data in the database. Okay, fancy. And then, the build script, there's some test coverage, there's some integration tests, and you saw a Chrome browser popping up on the screen. We also have 4 automated full system tests that are actually popping open the application and checking it out. So if I were to hit Control F5 and just build and run this application locally, which, by the way, the very first time I ran it, it would fail if there's no database, right? If there's a screen that's trying to or if there's some code that's trying to call out to a database, it's going to fail. All right. And here's the built-in weather forecast. And then here's an extra screen that actually queries the database. And these are the 4 records that I showed you in SQL Management Studio. All right. And then a few things just to whet your appetite. You want a way to know what the version number is, which in local, when you're doing local development, it's not going to have a version number, 1.0. But also, we want to know if this application is healthy. So you want to be able to see health check. Yep, it's healthy. All right. Now, if I were to show you the running application, check it out. There, right when we start up the application, we run whatever built-in health checks are a part of it, which we have 3 different health checks when the application starts, just to check the database is online, make sure it's running in a 64-bit process, that the web services are up and running. This happens to be a Blazor WebAssembly application, but this logging is from the health check. So if I were to pull this over here and run this again, notice that the health checks ran again. Okay, so let me close that down, and let me come over here and just give you a quick overview of this application. I'm not going to talk to you about Blazor. Any .NET application, these things apply. But let's let's use. I've been using ReSharper since 2003. It has so many features, but I'm going to use the architecture view, and I'm going to show the project dependency diagram of this particular application. And I always like to collapse it in a different way. Let's get some more space over here. I like to collapse it in this view because this really shows the structure of the Visual Studio solution. This is another really, really important part when you are creating a new development environment, a new Git repository, and automating DevOps. You want to make sure the structure of the code is not going to fall in on itself. The code needs to be able to hold itself up. Okay. And so this uses the onion architecture concepts, the onion architecture principles, and just I'll summarize real quick because I've done full-on presentations on onion architecture. Every Visual Studio solution needs to have a project that's called core. Let me just go back to this. It needs to have a project that is called core. and everything else references the core library, and the core library doesn't reference anything. Now, does it reference something? Yes, but nothing of importance. So let me look at dependencies, packages, and frameworks. Look, all it references is kind of the built-in .NET framework stuff. It references logging, but it only references abstraction. So core cannot call out to anything, okay? There will be no code in the core library that calls web services, that reads from a queue, that goes and opens a connection to SQL Server or any other dependency. Core does not have any external dependencies. It only has code that is the middle of your application. That's why we call it core. It's the core of the onion, okay? And think of these other projects as being outside layers of the onion, and they reference core. All the direction of references go towards the inside of the onion, towards the core. And so we have data access. That project includes all of our code that uses Entity Framework to call out to SQL Server, but it references core. Core doesn't reference it. And then we have UI.client, which is our Blazor WebAssembly. Then we have UI.api, which is just a project where UI.server is part of Blazor WebAssembly, but UI.api was a project that refactored the web services into its own subordinate library so that UI.server could act as the startup project, but we didn't have to have the project that had web services know directly about data access. Because if you're a web service, you're not going to be calling into SQL Server directly. You have no business knowing about data access. And so the abstractions are in core, but UI.server is our startup project. The startup project does have to know about all of the dependencies so that the services collection can be configured and dependency injection can be wired up. Then, of course, we have unit tests that references core. We have integration tests that has to know about all of it. And then acceptance tests, which are our full system test library. And then we have a database project off to the side that doesn't actually have any .NET references. Why? Because it's just a holder for SQL Server migration scripts, okay? And this happens to use the AliSQL simple command line migrations tool. DBUp from Octopus Deploy is also a great one. Redgate is doing a lot of heavy development on Flyway, their new product, but it's not rocket science. SQL Server migrations, there was a lot of argument on SQL Server migrations around the 2006 timeframe, but the dust has largely settled. You want to be using one of the migrations tools that have a directory of database change scripts, and the tool really just runs them in order. That's all it does. And so if I wanted to add a new column to this database table, I would have an additional SQL file that had alter table, and then I would add the column there. Okay, so I'm going to give you a quick tour of that application, and let's get back to how to think about it, all right? Okay, I'm going to start kind of from the beginning, and I want to go through the things that are really important. If you miss some of these, your life is going to be unnecessarily difficult, okay? Now, if you know exactly what you're doing in a certain area and you know why, and you see something that you disagree with me, but you know why you want it to be different, fine. I have no problem with that. But if you don't already have clarity in how you want to do a certain area here, then I would encourage you just to try what I'm suggesting, because 80% of the time, it works great and you don't even have to think about it. Okay. So I'm going to come back to build scripts. Cesar, you have a question. I'm going to come back to build scripts. My build script is vanilla PowerShell. It is just PowerShell. It is just scripting, super simple. I've looked at with interest the Cake tool, C# Make, and it's really interesting. And I plan to do some more trying out investigation. But when you're talking about scripting, PowerShell is effectively the Microsoft scripting language, and it's just so simple so easy. Something, should I introduce another tool? Well, you know what? I, for now, I've concluded if you don't need it yet, don't pull in additional tools yet. And so I encourage you to go to the GitHub repository that I shared with you and literally just go ahead and use that build script. If it's useful, clone the entire repository, look at the build script. Most of the variables have been extracted, or most of the specific magic strings have been extracted to variables at the top of the file. So you can just change some of those variables and it has all the things you need. But when you're thinking about how to start, it starts with source control. You need source control. Git has won the source control battles. And we're no longer talking about other source control systems like Subversion or Mercurial. We're using Git. All right. You want to make sure that you only have one application per Git repository. And when I say one application, I mean one Visual Studio solution. It is perfectly fine to have a web application, a backend batch job, and a database project in one Visual Studio solution, and they're built together, they're packaged together, that they are one, architecturally, they are one logical application, but you have multiple things that need to be deployed. But the multiple things that need to be deployed are still versioned the same. And so if they're versioned the same, then architecturally they are one application. You put them in the same Git repository. So you may have a software system that you choose to decompose into multiple software applications, and you put each of those software applications in its own dedicated Git repository, and that's great. What you don't want to accidentally do is create this custom directory tree in your Git repository and have several applications 1 or 2 levels down, because all of the DevOps automation tooling out there in the industry is optimized to run on the contents of an entire Git repository. It's made to clone the entire repository, build whatever is in the repository, test whatever is in the repository. Not saying that technically it's impossible to do it. It is possible, but you are going to be signing up for a lot more custom work yourself, and you're going to get a lot more automatic help from all of the tooling and products out there in the industry if you just follow this rule of thumb: one Visual Studio solution per Git repository. And applications that you've probably seen, some applications you've inherited that have gotten so big where you don't want to load it up all into one Visual Studio solution. You end up having different solution files that only load a subset of the projects, and you have multiple solution files, but it's on the same set of projects. Well, you've already got a mess on your hands when you get to that point. And so, you kind of breaking the rules already. But if you're in iteration 0 and you're starting a new application, we're not talking about brownfield, you're starting a new application, this is the way to go. One Visual Studio solution with, 7 to 10 projects in it, and that goes in one Git repository. And then your DevOps automation flows from that one Git repository. Then if you have 10, 20 different Git repositories because you have 10, 20 software applications, you're going to have 10 or 20 DevOps environments, DevOps pipelines, and you're going to have another instance of all these things that I'm talking about. Okay, this is the structure of a build right here. These are the steps. So when you look at the build script in source, know that this is what it's doing, okay? And the private build and the continuous integration build leverage the same build script. They have slightly different purposes. The private build is meant for the individual software engineer's workstation. That's where the private build lives. So we take the build script and we run the private build locally. And if you think about the notion of test-driven development and its definition of a single test, then you come away with the notion of arrange, act, assert, or set up and get ready, then do it, then check what you did. Okay, those are the 3 concepts. So arrange is set up and get ready. On the local developer workstation, when you clone the code, set up and get ready includes making sure that this application's dependencies are available. What I just showed you earlier was this application had a dependency on having a SQL Server database. It was something that the application it was a dependency and it needed it. And so guess what? The build script is responsible for creating that database locally. If the application is exporting some files to a directory, well, then we need to create those directories and know what the path is to them on a disk that we can get to locally. The best mindset for a private build is don't have it rely on the internet. You should be able to put it on a thumb drive, send it up to the moon, run it on a computer in zero gravity, and the private build script should work. You don't want to require the internet to be up and some shared server or some shared thing to be up in Azure or in your company's network in order for one of the steps in the private build script to complete. Recipe for disaster. Put everything locally. This is why it's called a private build. Private, not shared build, private build. Okay. This, you've probably heard of the inner loop of things that a developer does over and over and over and over and over again. The developer can spin and cycle. And then the outer loop is interact with the team. And then further from that, the team interacts with other departments, maybe product management. And then further from that, product management decides to send this version of the software out to its customers. And then further from that, customers are using the software and they encounter something and they provide feedback. Well, now that feedback needs to get back to the loop of product management, and then that feedback needs to get distilled, and product management needs to tell the team something that in the inner loop. And then finally, the team needs to decide what to do about it. And finally, there's a task, and the developer takes the task, and the developer is spinning on the inner loop and changes something about the software. And then there's some tests. So those are the inner loops. The private build exists for that inner developer loop. Okay, no dependencies on the outside. Now, the continuous integration build is for the team, okay? It's for the team. And whereas the private build kind of answers the question, I've done some stuff. Do I still have a stable code base or did I totally break it? Should I commit and push this up to my feature branch to have the feature branch pipeline even run, or is it a waste of time because I totally broke something, okay? The integration build answers a different question. The integration build answers the question, do the changes that work locally, when mixed with the changes that other team members have done, are those still good? Does it still result in a stable piece of software, or have the combination of those broken something? And now if I submit my pull request and get it merged into master, have I broken the software for the team, or is the software still stable and worth creating a release candidate build, right? That's the type of question, but it's the same steps. We clean the environment, then we stamp a version number so that all the assemblies have the version number. Then we set up environment, migrate database, talked about that. Then what's the core thing of a build? What are we trying to do? Compile. We're translating the text code, the code in C#, and we're compiling it to assemblies. We're compiling it to DLLs. Then once they're in DLL form, we can do some assertions. We can run some integration tests. We can run some integration tests and unit tests. And then after that, then we say, you know what? The build is good. And now we have some additional steps that only run in the integration build environment. And that is static code analysis for some additional quality checks. And then we publish the test results, and then we package up whatever projects are targeted for deployment to ultimately to production. And then we publish those packages. Okay. All right. Let's see. I'll pause. Get a couple questions here. One from Daniel. To be completely private, sometimes we need to mock a server to not call some third-party APIs. Yes, absolutely. You need to simulate some dependencies where in a deployed environment, yeah, we call out to a third-party API, but locally, if we want to run tests against something locally and have those run in our build, absolutely. We can't call out to that third-party system. We need to use some good old design patterns so that we create a simulation of calling out to that server. We're not going to stand up a third-party server local. Like for instance, if I was calling out to a web server to make a web server, a web service call for weather information for weather.com, I'm not going to try to set up something that actually simulates weather.com. Instead, I'm going to set up some code that is a stand-in for the class that is the gateway that calls weather.com. And I'll set up an abstraction, most likely an interface called, I don't know, iWeather Gateway. And there'll be one implementation of that interface that calls weather.com. And then the other implementation of that interface would be called Weather Stub. And there's whole books that are written on test doubles and simulators and classes that can mock up different functionality. And so there's lots of information out there, but ultimately you need to simulate something. You need to act as if the gateway needs to be swapped out so that your application is still calling the abstraction that you created in front of the third-party dependency. But the rest of the application doesn't even know that it's running locally. All right. Kevin asks, our team has used Cake for years. They're happy with it. However, we're starting to remove it to go to pure PowerShell. The reason is we thought the team would like it and it would be easier to learn and maintain since it's C#, but it didn't happen. So we decided to recently remove the extra dependency. PowerShell is now cross-platform, and so you've gone to PowerShell. Good. Hey, good comment. Thanks, Kevin. I appreciate that comment. Yeah, good to know. But I've loved just regular vanilla PowerShell. It's a great scripting language, and yeah, it works great. All right. By the way, the tools is not the magic here. The process is the magic, okay? Now, let's talk about pull request process. Automating DevOps from day one, all right? You want to put in place feature branching and a pull request process. And I just want to go back in before we write code, somewhere in your process, the definition of done needs to happen. When you're analyzing requirements, deciding how you're going to design things, maybe making some screen mockups, some different activities you do before you're actually ready to write code on a new change or a new feature, we need to specify what scenarios this new software capability needs to support. And think about it, that's test scenarios. So specify test scenarios as part of the process. If there's a new screen, you're filling out a form, there's always a happy path and a sad path. There's a happy path where you click the button, you're done. The sad path is where you type in some stuff, you click the button, but you have some validation errors, and so we don't actually execute the capability. We say, oh, there's an error, you need to fix some stuff. So everything tends to have at least two scenarios because you have a happy path and a sad path, or a happy path and an exception path, whatever you want to call it. So now we have two scenarios. Those scenarios are perfect for full system tests, full system acceptance tests. So on the engineer workstation, we change the code, we do a private build, we commit and push the code. Then on the team's build server, the continuous integration build runs all those tests, static analysis. Then on our feature branch, we have automation that automatically deploys the application to our TDD environment, does the deployment, and then runs the full system acceptance tests, which if you have a new change, you have two new scenarios, two new full system tests, happy path or sad path for a new screen. And then when all of those pass, now you've got your testing pyramid. You got your unit tests, you got your integration tests for all your individual dependencies, and then you have full system tests that have run and passed on a completely deployed environment. Now you know you're ready to submit a pull request. And when you submit the pull request, that's when we couple an inspection, which is basically just making a checklist for your standard pull request. Get with your team, create a checklist, and you're basically just adding a part of your process. You know what? If I hit the approve button on the pull request, that means that I have checked every item in our team's checklist, and I'm hitting that approve button, and that's what I'm asserting. And now we pull the code from the feature branch back into master. And then on master, guess what? It triggers the integration build, does the deployment, does the full system tests, running it again for the combination of your branch with whatever's in master. And now we have a real release candidate that can go onto our manual test environment. So when we're thinking about release candidates, think about what has to be deployed. Okay, this is another part for automated DevOps that you need to do in iteration 0. Whenever you're laying down a new Git repository, do this right off the bat after your integration build succeeds. And I put it in the same PowerShell script as the build. It's just a package task. And so let's see if we have a web application. Great. We're going to have a deployable package for a web application. We have an offline job that just sits there and watches a Azure Service Bus queue. Okay, that's just an offline job. And whether or not we deploy it as a service worker or we deploy it to an Azure function or app service, doesn't matter. It's another deployable process. So it needs to have a package. The SQL Server database schema, it's going to be deployed to Azure SQL. It's a package. And our full system acceptance tests, those have to be deployed to our build server agent. And so that's a package. So we have 4 different packages, and then we need to push it to either Azure Artifacts or the NuGet server inside Octopus Deploy. Those are kind of like the 2 choices in the industry. There's a few smaller choices, but these are the big guys. And the NuGet format is still just the best drop dead simple package type. I mean, after all, it's just a zip file with a different extension and an additional manifest layer built on top of it. Could you use regular old zip files? Sure, you could. But when you do that, you're going to end up embedding more information in your naming convention of the file than is necessary. So I found the NuGet package to be super easy. And Octopus Deploy also has a open source tool that kind of layers on top of NuGet. That is a tool that installs into .NET.exe. You actually, when you look at the build script of this application, you'll be able to see that in use. All right, and of course, if you look at Azure Artifacts, this is what it looks like with three deployable pieces of our application. Well, this sample application didn't have the offline job, but I just threw that in for illustration. Okay. And for deployment, we're talking about iteration 0 again. For deployment, we want to deploy to a production-like environment on the first day of iteration 0. Now, you might say, hey, this is going to take multiple days to get all this set up. Well, if you were inventing all of it, and if you were figuring out every step, how it needed to be, and creating all these patterns from scratch, yeah, I'd say I would agree with you. But you don't have to do that. All you have to do is grab the Git repository that I showed you the URL for and just modify it. Use it as a template. You don't have to invent any of this stuff. And if your application isn't a Blazor app, if it's something else, great. Delete the Blazor projects. They were just stand-in projects anyway. Keep the build script, keep database, keep the core, keep your unit tests, keep your integration tests, and throw in a WPF project or whatever your application needs to be, okay? But use templates. Use the build script template that I gave you. If you were to, I challenge any of you, clone that build repository and just run click-to-build.bat, which by the way, just calls build.ps1, and it'll run for you, okay? It'll run for you. And then now you do need to have SQL local DB installed locally, but Visual Studio, unless you've modified it, Visual Studio defaults to installing that from scratch anyway. And then when we're deploying, we need to choose our deployment architecture, okay? And this is kind of out of scope for today. We only have about 10 more minutes, but you have a progression of choices on what environment types you want to use. For a long, now you may have some scenarios where you have to install it in your own physical data center cabinet where you could put your hands on the actual hard drives that are storing the data. And some customers will require that in some situations, but a large percentage of regular business software, there's nothing holding it back from going straight up to Azure. And so I always look to Azure serverless resources first, and then just make sure that there's not a dependency or requirement why that wouldn't work. So that's my go-to. And Azure App Service with Azure SQL Database, and then of course add on Azure Service Bus, SignalR, all kind, whatever other resources to complement that. But as far as starting something new, you always tend to have a database. You always tend to have some relational data, and then even if we have file data, blob data, JSON data, we kind of layer it on top of that. But you always have a SQL Server database, unless it's just a highly specialized microservice that's really small and just incoming and outgoing. And so that's been my favorite. Now Azure Container Apps builds on top of App Service and gives you the power of a hosted Kubernetes cluster where you don't actually have to set up and maintain the whole Kubernetes cluster. It just kind of runs it for you. You throw a container into Azure Container Registry and it just deploys and runs it. So that's pretty cool. And I've done some previous webinars a few months ago on .NET 7 and Azure Container Apps specifically. So if you're interested in that, just look in our webinar archives. Okay, now to close up iteration 0, when we're deploying, another really important part is that when we deploy to the TDD environment, to the UAT environment, to the production environment, we deploy the same release candidate, meaning we deploy the same set of versioned packages, okay? The same set of versioned packages. We don't, when we're deploying to TDD or UAT, we don't go back to the Git repository, clone the Git repository, and compile again. If you ever hear somebody say, we need to build to UAT, or we need to build to production, and you find that they're actually compiling the code again, no, big mistake. Every time you create a build, you're creating an unproven release candidate. That's why we call it a release candidate. It is a candidate for release. We don't know that we're going to release it. It's a candidate for release. We have to run it through our unit tests, integration tests, and full system acceptance tests in a fully deployed environment. And then we need to deploy it to UAT and have humans check it out. Then it's not a release candidate anymore. It is a pending release, or it is a general availability release. It's an actual release, not a release candidate, okay? So we don't build to production. We take a numbered release candidate that's already been to every stage beforehand, and then we deploy that exactly to production. And that really constrains the surface area where it would even be possible for new bugs to slip in. So when you're thinking about these 3 different environments, you want to make sure that when you deploy to production, you are doing the least amount of steps. And you want to make sure that every single step that you use when deploying to production has been done in multiple environments ahead of production. In our test automation environment for TDD, we're gonna migrate the database, deploy the application. We're gonna run our health checks. We're gonna load some static data that just needs to be in every instance of the database. But we're gonna do a lot more things. Think about running acceptance tests. There's no way we're gonna run acceptance tests in UAT, because just the test setup alone is inserting and deleting records in the database to set up a certain scenario. We would blow away, test data that manual testers rely on in UAT, and we would accidentally blow away customer data if we did that in production. So no way do we do those things in UAT or production. And when it comes to loading test data, we don't do that in production. We do it when requested in UAT. Sometimes we'll recreate a test environment, or we'll set up a secondary manual test environment on demand. But the important part is every step, everything that you do to deploy to production, you want to make sure that you have practiced it many, many, many times before. All right, so coming back to this overall process, this is the process that you set up in iteration 0. You don't have to invent all of it. You've got plenty of samples, one of which I just gave you. Just steal that stuff and modify, use it as a template, and go to town. And you're gonna be rolling. You're gonna be rolling quick. Remember, your mindset first is to establish a high bar of quality, and you do that with your multiple layers of test automation and static code analysis. I didn't show you this one part in the build script. I'll make a kind of highlight it now, but in the build script, I'll just go to the part where we do the compilation. We do .NET build, right? And here's all these command lines. You don't need to figure out what command lines you need. You want to be able just to use these from scratch, but check it out. Here's a property. Treat warnings as errors equals true. This is your built-in baseline static analysis. Now, you could go into every single Visual Studio project and you could check the box to treat warnings as errors. The reason that people don't do that by default is because it's annoying. It's a terrible development experience to have it always treating warnings as errors, because you're doing something temporary and now it's treating it as an error and you can't even compile because Visual Studio is warning you of something. It's like, yeah. I need to figure out how to get this code working and then I'll fix the warning. But you don't want the warnings to block you from even debugging something while you're working on it. This is why people don't turn on this switch, is because it gets in the way. Well, then people leave it off. So the important part is you optimize your development experience by leaving it off by default in the project so you can get stuff working. But in your build process, you have it turned on. And that way, you don't have any code that's lighting up with warnings actually making it in to your software. Okay. So just things like this, things like this to optimize the flow. And then, of course, the integration build, the packaging and putting in release management, and then the 3 different types of deployed environments. Again, that's the minimum. Plenty of teams have 4 environments, 5 environments, or they have the 3 environment types, but they have like 6 parallel manual test environments because they have different groups that need to test out everything else. That's totally fine. But you can never get away with fewer than 3 sequential environments because they all serve a totally different purpose. Production, internal manual testing, and test automation. Totally different audiences, totally different purposes. All right, I did answer quite a bit of questions along the way, unless some more were coming in, but I know a lot of information to cover. At ClearMeasure, we live to empower your software team. And with new customers, we do a lot of our DevOps inspections, and we'll also do total software inspections, including inspecting the architecture if that's helpful for you. And then also software project jumpstarts. If you're starting a new project and you want to get your team to delivering at a really quick cycle rapidly, that's what our software project jumpstart is for. If you're launching a new product and you want to get to market in 3 months, that's what our software project jumpstart is for, to get your team going fast so that you're not into month number 2 and you're just still trying to figure out how to deploy and how to get something out. Iteration 0, by the way, doesn't even have to be a full iteration. Doesn't even have to be a full week. It could be a day, a single day. And we've done this so much. We worked out all the different parts of the pattern to get you deploying to production, have everything set up in a single day so that your developers can just crank on the features that you want in this new application. So if we can help with any of these products, let us know. ClearMeasure.com has all the information. We are doing these webinars at least monthly. So check our website, sign up for our newsletter, and download the poster, the free book. And I think I've answered all the questions. And by the way, if you want to know how your team is doing, I don't have a link to it, but if you could just go to clearmeasure.com and look for the self-assessment, you can take the self-assessment and kind of see how your team's capabilities stack up with other teams out in the industry and how you're doing, and maybe highlight some of the things that you need to work on. So that's that. All right. Well, thank you again so much for your time. And I'll stick around if there are, any kind of questions or discussion, but thank you so much for your time, and have a great day. God bless.